Okay, so we are looking at these dimensional analysis questions. Okay, we just want to determine the dimensions of some of these quantities. Okay, and some of these questions we are deriving the relationship between different what quantities. Okay, so when you talk about dimensions, this is what you mean. Okay, so remember when we are doing chemistry yesterday, I showed you guys what we call as the SI units. Okay, so you have 7 of the SI units. So when you're dealing with dimensional analysis, the most encountered SI units are time, mass, and length. Okay, so time, we said it is measured in what? Okay, so we said time is actually measured in seconds. Okay, and then we had mass, which was measured in what? Grams or kgs. It's just the same. And then we also have length or distance or height. Okay, it's just the same thing, which is measured in meters. Okay, so these here are what we call as the units. Okay, but these units here have what we call now as dimensions. So this is what we are going to be using in dimensional analysis. So if you talk about time, its dimension is just a capital letter T like that. That's the dimension of time. Okay, and then when you talk about mass, its dimension is a capital letter M. Okay, and then length, its dimension is just a capital letter L. Okay, so we are mostly going to be dealing with these guys here. Okay, in all our questions. So those are dimensions, and then these are units. Okay, right, and then these are quantities here. So let's look at the first question there. So if you have any questions, please feel free to just unmute yourself and ask. Okay. All right. So let's look at the first question here. They're saying, where's the first question here? Okay. So number 26, they're saying a wave equation is given by lambda is equals to C over F, where this lambda is wavelength. Okay. So this symbol is called the lambda, where the lambda is a wavelength, C is the speed of light, and then F is the frequency. Okay. So now the question comes, they're saying determine the dimension of the C. Okay. So for you to determine the dimension of the C, you have to know the dimension of the other quantities that we have there. Okay. So this is what we have here. We have lambda is equals to C over F. Okay. They said C is the speed of light, and then F is the frequency, and then this lambda here is the what? Is the wavelength. Okay. So we are going to make, first of all, this C to be the subject of the formula. So we are going to say C is equals to lambda multiplied by what? Frequency. Okay. And then after this, for us to determine the dimension of this C, we have to know the dimension of this lambda and then the dimension of this frequency. Okay. So we know that this lambda here is the wavelength. So the wavelength is measured in what? Okay, so we are going to replace this lambda with the units in which it's measured. Okay, so lambda is a length. So length is measured in what? In meters. And then multiplied by this F. Okay, now this F is the frequency. Okay, so what are the units for frequency? Okay, so frequency is found by dividing 1 divided by the period, right? Okay, so that period is just the time. So period is measured in time. So I mean this. So frequency is equals to 1 over the period. So this period here is measured in seconds. Okay, so 1 over seconds gives the units of this frequency to be 1 over S. Or if you want, you can bring this S on top there. It means it will have a negative power. So it will be S to the power 1 like that. Where did I write something like a 6 here? Okay. So the units of frequency, okay, are just S to the power minus 1 or second to the power minus 1. Okay. So where there's frequency here, I'm going to put S to the power minus 1. Okay. So we know that S measures the time, right? Okay. So these here are the units. So for us to find the dimensions, we're we're just going to replace them with their dimensions. So M is mass. I said mass, its dimension is a capital letter M, like that. I mean, this is length, not mass. Okay, so this is a meter, right? So it's a distance. So length, its dimension is what? We said it's L. And then this is the time. Its dimension is what? T. And then you're just going to add that power -1. Okay, so the dimensions for this speed of light are just length multiplied by time to the power -1. Okay, and it's true because we know that speed is what is measured in meters per what? Per second. So this meters per second is what we had here. Okay, and then we're just replacing its dimension. So any questions there? Okay, no questions. I'll move to the next question then. Okay, so the next question now is question 27. They're saying in the equation, Q is equals to IT, where Q is the electrical charge, okay? I is the electrical current, and T is the time. Find the base units and the dimension of what? Of the Q. So this is a simple question here. So let's write it on the board here. So we have Q is equals to I multiplied by a small letter t like that, okay? So we want to find the base units of this guy and the dimension of this guy. So what are we going to do? To find the base units of this, we're just going to multiply the units of the electric current and the what? The time, okay? So what are the units for current, electric current, okay? We saw yesterday on that table for base units, we said current is measured in what? Amperes. So where there's I here, I'm going to put ampere. And then I'm going to say dot. What are the units for time? It's just seconds, okay? So the base unit for this guy, which is the charge, the electric charge, is just what? Amperes multiplied by the second. Okay, so these are the base units. And then they have a special name, okay? If you can remember from your grade 12, we said charge was measured in what? In what we called as coulombs, okay? So a coulomb is defined as 1 ampere multiplied by 1 second. That's a coulomb. So a special name for this here, ampere multiplied by the second, is what we used to call as a coulomb, okay? Represented by a capital letter C like that. Okay, so these are the base units for charge. And then now let's find the dimension for this charge, okay? So the dimension are going to be, where there's A here, since it's electric current, okay? Electric current, its dimension is just a capital letter I like that, okay? And then we are multiplying this capital letter I by the dimension of time, which is a what? A capital letter T like that, okay? So this charge has the dimension of IT, and then it has the base units of amperes multiplied by what? Second. Okay, any questions there? So this was, is it question 27? So any questions there? I'm pretty sure this is straightforward, right? We can move to the next one. Okay, let's look at question 28. Okay, so question 28, they're saying given the equation for the gravitational force, which is given by F is equals to G, okay, multiplied by capital letter M, small letter m divided by R squared, where the F is the force, M, the capital M and the small letter m are both masses, and then they're saying R here is the distance, okay, and then G is the gravitational what? Constant, okay. So now the question is, determine the dimensions of this G here. So we are determining the dimensions of this G. So what are we going to do? Okay, we just have to make G the subject of the formula, okay, and then substitute dimensions for each and every quantity that is in that formula. So we have force, mass, and distance, okay. So let's write this guy here. So we have F is equals to capital letter G, and then we have capital letter M, small m divided by R squared. So we know the dimension of this F, okay? We know for the length, we know for the mass, but we don't know for this G. So what are we going to do in order to know it? We are going to make it the subject of the formula. So we are going to cross multiply here. Okay, so this R squared will multiply by the F squared, and then we are going to remain with G M here. So it should be G M is equals to F and then R squared. Okay, so this means that our G will just be equals to what? Just be F R squared divided by capital letter M, small letter m, like that. Okay, and then from there now, we can substitute with their, first of all, we substitute with their units, and then from the units, we can tell their dimensions. Okay, so what is force? What are the units for force? Remember that force, we find it by multiplying m multiplied by a. So this m here is the mass, okay? That m there is the mass. So where there's m, I'm going to put grams, okay? And then multiplied by the acceleration. What are the units for acceleration, if you can remember, okay? So we said acceleration is just meters per squared, per second squared, okay? So these here are the units for acceleration. Okay, we know from our grade 12. So where there's a here, I'm going to put m per squared second, like that, okay? But when you're dealing with dimensions, always make sure that whatever is in the denominator comes on top, because this guy here is the same as I write this. I write gm, and then I'm dividing by s squared, okay? So when you're finding dimensions, always make sure that you don't have a fraction of units, okay? So this s to the power 2 has to come on top there, okay? It has to come on top. It needs to be on top. So what are we going to do for it to be on top? This power will become a negative power. So it will just be gm s to the power minus 2. Okay, why can we do this? Because we have this property that if I have y to the power n over 1 like this, this is the same as y to the power minus n, like that. Okay, no wonder we're able to change this. So it means where there's f, okay, I'm going to put these units here. Okay, I'm going to put these units here. And then where there's r, we know it's distance, so we are going to put what? Meters. And then where there's here, we're just going to put what? Grams. Okay, so let's do that now. Okay, so let me just clean this. Okay, so well, we are going to say is equals to, the units for the force we said is this. So it will be gm s to the power minus 2. Then multiplied by, what are the units for r? R is the distance. So it is meters. Since r is squared, we're going to say squared. Then divided by m and m, okay? We're going to say g and g here. Okay, so we can see that on top there we have m here and m there. So we can combine those m. So to be g m to the power 3, and then s to the power minus 2, and then down here to just be g multiplied by g. And then from here we can see we can cancel one of these g's, okay? So it means this is equals to m to the power 3, s to the power minus 2 divided by g. Okay, so here now we can substitute with their dimensions, okay, to find the dimension of this g here. So we're going to say dimensions of g are just equals to, this m there represents the distance. So we are going to replace with its dimension, which is L to the power 3. What is the dimension of s? S is time. So we are going to replace with t to the power 2, minus 2, and then divided by, what is the dimension of g? This is mass. So we are going to say m. Okay. All right. And then once we do this, remember I said you don't have to leave it as a fraction. So this m has to come on top. Okay, so when this m comes on top, it will have a minus 1. So our dimension will just be L to the power 3, t to the power minus 2, and then m to the power minus 1. So these ones here will be the dimension for the what? Gravitational constant. Okay, so any questions there?
I've got a question.
Yes, you can ask.
Do we carry the base units for mass as kg or as grams?
Okay, so when you're dealing with dimensional analysis, the most they use grams, so you use grams here. But even if you put kg, it won't change anything. Hello, the one who asked the question.
All right, understood.
Okay, so when you're dealing with dimensional analysis, they must use grams because most of the units for the quantities that they use or that are involved are in grams something. Okay, so make sure you use the grams here. Okay, and then let us look at something different, okay, because here we're just finding the dimensions, but we can also use dimensional analysis to derive relationships between different quantities, okay? That's what we are going to do on question 29 there. Okay, so question 29, we want to derive the relationship between different quantities. So let's read this question 29. So they're saying, using dimensional analysis, derive the relationship between the period of a simple pendulum, okay, its length, and the acceleration due to gravity, g. Okay, so we are deriving a relationship between t, okay, and L and G. Okay, so whenever you have such a question here, okay, whenever you have such a question like this one here, we always have to write it in this way. Okay, so we are deriving a relationship between this T and L and this G. Okay, so what you're going to do is that you're going to write, let us assume that T, okay, is proportional to this L and G. Always, this should be your first statement when you're deriving a relationship, okay? So T is proportional to L and G. And then what you need to do is that you have to raise this L and this G to a certain power, so an arbitrary power. So raise the G and the L to a power that is a letter, any letter of your choice. So let's say L to the power A, okay, and then this G to the power B like that, okay? And then from this now, we can drive the what? The relationship. So this is the first statement that you always make when you're deriving a relationship, okay, between different quantities. So we are going to say T is proportional to L to the power A, G to the power B, okay? So now, our job here is just to find the value, okay, of this A here and this G. Then we would have driven the relationship, okay? And then another notice to note here is that this symbol that I've written here, okay, this symbol here is always replaced with, okay, an equal sign and K. So this symbol here is the same as equals to, and then you put K in front like that. Okay, so wherever there's this symbol here, I'm going to put equals K. Okay, so let's do that. So we are going to say that T, and then where there's this symbol here, I'm putting equals and K. So it will be equals and then K, okay, and then L to the power A, and then G to the power what? P. Okay, Jack has raised the hand. You can ask a question if you have a question. Or maybe it's a mistake. Okay, anyway, so after you do this now, okay, you have to get the dimensions of this L and the dimension of this G, okay? So we know that L is length, okay? Length is measured in what? Meters. So we're going to say this is equals to K. Where there's L there, I'm going to put M to the power A. And then this is G, okay? So G, they said, is the acceleration due to gravity. So the important word there is acceleration, okay? So acceleration, what are the units for acceleration? Okay, it's just meters per second square like that, okay? or simply meters s to the power minus 2. So I'm going to use this guy here. So here I'm going to write m s to the power minus 2 to represent this g, and then remember it has the power what? B there. So this is the relationship that we have now, okay? So after replacing the units now, we can replace with their dimensions. So I'm going to say t, which means the period of the pendulum, is equals to k, okay? And then here we're just going to put the dimension of this m. So the dimension of the m there is just what? L, because that's a meter to the power a. Then the dimension of this m again inside there is still L. Then the dimension of this s is t, okay, to the power minus 2. And then outside there are what? A b. So this is what I have here, okay? And then remember that the units for a period are what? I said period is just the time, right? You remember, guys? Okay, so period is the time. So whether there's t here, I can also put I can put an s, and then I'll still replace it with the t, okay, because the dimension for time is a t, right? Okay, so once you reach here, okay, once you reach here, what you're going to do is that you're going to distribute this b power to the l and to the t to the power minus 2. So it's going to be t is equals to k l to the power a, and then this b goes to the l, so it will be L to the power B, okay? And then, okay, and then it's T multiplied by this minus 2 multiplied by that B. So it will be minus 2B like that. So this is what we have, right? Okay, so we know that L and L are the same bases, so we can add their powers. So it will be K, okay, and then L to the power A plus B, okay, and then T to the power minus 2b. So this is what we have here. Okay. So now when you reach here, you remember your goal, or our goal here, is to find the value of a and b. So when you reach here, what are you going to do? Okay. You're going to look at your left-hand side and your right-hand side. Okay. So we see that on the left-hand side there, okay, we see that on the left-hand side there, we have a t only, but on the right-hand side, we have L and t, okay? So what are we going to do? It means this t is just to the power 1, okay? And then if I added an L here, it means this L should be to the power 0. Because remember, any number raised to the power 0 is what? Is 1, okay? So this L to the power 0 is the same as 1. So I'm going to equate the powers of L on my right-hand side here, okay, to the powers of L on my left-hand side. And then powers of t, I'm going to replace with the powers of t. So what we mean here is that this 0 is going to be equals to a plus b. Then this one is going to be equal to minus 2b. Okay, so don't worry about the k. The k is just a constant. A constant doesn't have dimensions. Okay? So we're going to say 0 is equals to a plus b. And then on the other hand, we have 1 is equals to minus 2b. So this is what we have, right? Okay. And then from here, we can see that we can find the b from here. We can find the b from here. So what are we going to do to not find the b? We're going to say b is equals to, then we divide both sides by minus 2, even this side by minus 2. So it means we have minus 1 over 2 as our value of what? B. Okay. And then since we have the value of b here, it means we can find the value of a. So it means that 0 is equals to a plus, okay, what is the value of b? Minus 1 over 2. Okay, so I take this minus 1 over 2 to the other side. So it means a is just equals to what? 1 over 2. So this here is the value of what? A. So we are done with the question. We found the value of a and we found the value of what? B. So now let's replace these guys back into the what? The equation that we had. Okay, we replace these guys back into the equation that we had. Okay, so remember our equation was, we said it was T, which is the period, is equals to, okay, K, and then we had L to the power A, and then G to the power B. Okay, so let us replace those A's and the B. So this is going to be equals to L to the power half, okay, and then multiplied by G to the power minus half. Okay, and then from here we can see that K and then L to the power half. Since this guy here has a power half, okay, it can go down there. So it becomes G over what? It will become L power half over G power half, okay, by the properties of a negative power. No wonder I've been able to move this guy into the denominator, okay. From here, we see that we have a common power of this L on this L and on this G. So what are we going to do? We are going to factorize that power, okay. So it will be T is equals to K, and then it will be L over G, and then the power will be outside. It will be like that, power half. Okay, and then what do we know if we have a power half? What does that mean? Okay, so power half is the same as the square root, okay? So if you say square root, this guy is the same as, let me say square root of A. It's the same as A to the power 1 over 2. So power half is the same as the square root. So this would be the square root of L over G. Okay, so this one here is the relationship between the period of a pendulum and the length and the acceleration due to gravity. And then this K is just a constant, okay? Just a constant of who? The gravitational force, okay? So that's just a constant. So you can end here, okay? But there are some questions where they give you the value of this K, okay? So this value of K, you can only find it by experiment, okay? So in some questions, they do mention that by experiment, K was found maybe to be 2x, okay, or 2p, whatever. So it means what? Once you reach this point here, you can replace this K with the value that you've been given, that was found by the experiment, okay? But if you're not given any value, like in this case, just leave it like that, okay? So this here is the relationship between the period of the pendulum, the length, and the gravitational force. Okay, so any questions there, guys? Any questions there? Okay, seems there are no questions. Okay, so I'm going to end here, but I'm going to give you guys a task, okay? So make sure you try out the questions that I'm going to give you. So the questions, there are two of them, number 30 and number 31. Okay, so this guy here, this guy here. So try them out, and then you can send the solutions in the group, or you can send to my email. Okay, then I'll be able to guide you if what you're doing is correct or not. Okay, and then later on, I think tomorrow, I'm going to send the solutions to all the questions that you can see here. I'm going to send the solutions so that you can pass through at your own time. Okay, so if there are not any questions, I say have a blessed night and thank you for attending.
Thank you.